So I thought we would do another Coulomb's law problem because it's something that is probably new to most of you guys. So this one we're going to actually rearrange the formula, and this will be good practice because this is a skill that you're going to need to have throughout the year. So a negative charge of negative 6.0 times 10 to the negative fifth coulombs exerts an attractive force of 65 newtons on a second charge that is half a meter away, 0.5 meters away. What is the magnitude of the second charge? Okay, so I'll let you get that there in case you want to write that down. So I couldn't read my own writing, that's pretty bad, but what we have here is we have a charge. They have given us a number here that is 65, and then they wanting us to find the second charge because they're giving us the radius. So what I do is, my first step is I write down Coulomb's law. And then I want to isolate this Q2 away from everything else so I can solve for it. So my first thing I do is I multiply both sides by r squared. So the r squareds cross off on this side. And we see that r squared now moves over to this side, okay? And since we're multiplying, it's on top, it's not on the bottom. It's on the same line as the force, okay? And then my next move is to divide both sides by the k and the q1. And you can see me doing that here. And then I will cross that off, okay? And since we're dividing, you look over here and see that's on the bottom, and then I just plug in. There's my 65.5 squared, okay? And that 0 is important because that tells me I should report in 2 sig figs, because that's 2 sig figs. If it was just 0.5, we would only report 1 sig fig. Then there's my constant right there. I still put in my units for my constant, very important. And then there is my other charge, okay? Now, they said it's an attractive force, and so if this is negative, I know that my answer is going to have to be positive, and that my overall force, if it's a force of attraction, is going to actually be a negative answer. You could put that negative in there and then it spits out the answer correctly, or you could just do the problem as given and then realize even though it gives you a negative force, it's an attractive force, and so I know it's going to have to be positive. Regardless, what you get is, when you plug in and do this correctly, 3 times 10 to the negative, I didn't have my negative on there, fifth coulombs. 3 times 10 to the negative fifth coulombs. Now, watching me do it is one thing. What you really need to do is, shut down the video, write the problem down, and then solve the problem again. Go back, look at the Coulomb's law problems on the assignment.